Welcome. A couple of videos back, I made this drill press vise for my brother, and it's back here, not for repairs. It's still working. The problem that he's got is the drill press table of his drill press is way too small to accommodate this vise. So my idea behind this project is to replace this table and upsize it. Now this table is stamped piece of sheet metal with a bracket on the front that's welded on. Everything is welded, it's stacked in a couple of places, and this thing has got quite a bit of rock on it in all directions. So yeah, and as you can see, it's also well rusted. So he asked me to make him a replacement drill press table, and this is where this guy is coming in. It's a nice beefy chunk of aluminium. My idea is to make it at least 10 millimeters thick. So I'll surface this end here until I get it to clean up nicely around the edges, and to have this vise fit on it nicely. As you can see, this table will be wider than the vise, which is perfect. Doesn't need to be as long, because my plan is to tap 4 holes in the table itself for mounting. That will give him a range of movement on here that should be suitable for moving or positioning this vise wherever he needs it. Now if you open the vise up, the jaws up to this point here, you've got a piece of wood in here. He's doing woodworking. The chances of you ever needing to have the vise sitting here is very slim. It's going to look a bit funky because this hole here will be off center, because I need to keep the hole in line with the spindle. So yeah, this is going to be a nice challenge, because the reference surface is non-existent on this piece, and I need to get it as close as possible. Alright, enjoy this project with me, and let's see how it turns out. Okay, the only reasonable reference that I have is this bottom face here and these 2 ribs. I need to remove, this is not really a problem. Even these corners are not a problem, because my vise jaws has got a cutout on top, which I use for small part holding, and that should clear this raised sections. So if I install it on the vise, I can locate it until I find the best spot on the bottom. Now if it's a little bit out, it's not a train smash. The only thing that matters is this top face, and this face needs to be square to one another, and the sides as well. I think this should take care of 4 sides for me, the top and those thinner edges around the sides there. Once that is done, I can focus on this face that's going to register to the drill press itself. Just a quick note, I'm not clamping very hard, so I'm going to take very light cuts on this. Yeah, almost got full cleanup here. So I'm gonna take another couple of, I think one more roughing pass here. The first cut was around about 2 millimeters deep because I only had the border to clean up. Second one was 1 millimeters, and the last one was 0.5, and the surface finish is reasonable, and that's on an aggressive feed. So I'm going to take one more half mil pass and then see what it looks like, and then decide from there how much I'm going to take off. So the next roughing cut will be off camera, and I'll bring it back for a finishing pass. Okay, I was trying to edge fine between these two surfaces here on both ends, and the travel of my machine is way too small. So what I'm doing now is I'm just touching off on the best surface on the edge, and then cut in 1 millimeter from there. This is a bevel or the draft angle, so I'm gonna clean up the first side and see how it goes, and see how much I must remove. So in order to machine the two sides, or both, basically these three sides, I will need to rotate my vise and trim it for each and every operation. Now, as you can see here, it's a lip hanging over, so you also need to find the best spot on each end. On this side is not that bad, except for the bump there, and there's a little bit of an overhang. Yeah. And on this side, I've got a big lip here, and looking at the whole surface, this little spot here is the best I can register from. Now, looking at this round here, I don't think it's going to clean up properly without taking off a massive amount of material, which I don't want to do. From the top, it looks like about 3 millimeters that needs to be removed in order to clean it up. So I'm not gonna clean it up completely on this edge here. The front face will be done on a different operation, on an angle plate, so I need to clean up the entire face and drill a hole here in the middle. So yeah, that's a thing of castings. It's a challenge on its own, and something that I really enjoy. Alright, so to move the vise and redo the whole trimming process. Now, no, this is not the most accurate, but for what this project is, it's good enough. I'll just find the best spot here. Right, from there I'm going to remove 2 millimeters. I've removed 2 from this side here. I'll remove the same amount all around, except for this face at the back. You know what they say about clearance? I only have 6 millimeters of room spare between my boring head and the part. So yeah, if I need to take measurements, I'll need to move the part out of from underneath the spindle. These pressed carbide boring tools are probably the worst things you can buy. If you look at the edge on the sides here, you can see it's been rubbing all over. They don't cut in proper clearance on these things, so they tend to chatter and rub, cause a lot of heat and friction. So this is not working. I don't want to buy now a piece of high-speed steel to grind it up and cut it up to length in order to fit it for one project. So I'm going to rethink my strategy with a boring bar, because I want to use an insert type boring bar that I know that will cut or do a decent cut. So yeah, it's going to be a bit of creative thinking here and another setup. Okay, this is a Cockamani setup that I came up with. To use the angle plate from my rotary table, and I've lined it up with the exact end mill that I've used to drill this hole. And it also happens that one of my engineer's parallels and the scale or rule happens to be the exact height that I needed in order to get alignment here. So yeah, now I'm going to put my boring head in the chuck and then work it from there with my insert type of boring bar. That's a lot better. Right, this will be the last cut and then we'll measure up. I was aiming for 25. It's a little bit over, but it's not a train smash. It's around 2000s. Right, I think the boring went very well. A little bit of chatter, but what can you do? Now this recess that was cut into the original table had a bit of play in it. It was over by 0.2 millimeters, which is quite a large amount. So I've reduced it a little bit to have a tighter tolerance. And yeah, I think my setup using the lathe was reasonably successful. And I'm also happy that the bottom came out nice and flat, because the insert is at the angle. It's a CCMT insert, so it only took a 0.25 millimeter cuts at a time. The insert's nose is 0.4 millimeters, so that means it's not 0.4, it's 0.2. I think I'll have to look it up. But anyways, I took it as thin as possible so that I can have a parallel surface at the bottom, or else it would have been stepped. Right, so now I must focus on this hole here. But my brother asked me to make it a 40 millimeter hole, also with a boss in it. That will allow him to use his 38 millimeter hole saw, which he uses regularly to cut through the table, and then have a plugs put inside here for smaller diameter holes. Okay, I've got it fixed upside down on the table. I've already found center and position from the back edge, which is 83.34 millimeters. Don't know why it's such an odd size. It doesn't even make sense in imperial. But anyway, this hole cannot be drilled exactly in center from the back to the front because of the spindle position. Even though the table is bigger, the spindle position stays the same. Now I've got my mist cooler set up here. Now from the last time which I've made this little block, I've now added a ball valve to save me a trip to the compressor and back to shut off the air. So if the sound is muted, it's because of the noise of the compressor. It will completely obliterate the sound, because it's about 3 times louder than the machine itself. So yeah, this tip of the drill bit is a bit wobbly. I'm not expecting this hole to come out exactly square and in the middle. So after this process, I'm going to bore it out with a boring head. Now the 40 millimeter also is still the most efficient way of auging out a large hole. Now what I'm going to do is just going to add a plate underneath. So if I break through, the tip will hit the plate and not my table. It's to get creative with my fixturing here. Now the bottom is not machined, so I can't use that as a reference. So what I've done is I've clamped it to my engineer's parallel so that the top face will clamp underneath the slip of the engineer's parallel, which is square to the bottom face. And then on this side I've used G-clamps to level it out. Now I've used my inclinometer to make sure that everything is square to the bed and it checks out. Now I haven't removed or changed any settings on my boring head since the last time I've used it, so I can just continue from this point onwards. Make my first half mil adjustment. It will be at a half mil on a radius, not a radius, a diameter. So it's quarter mil cuts that I will be taking. Reason for that is so that I can get a flat bottom. Now I'm only going to cut this little recess here around 2 mil and 3 mil deep. 2 mil wide, 3 mil deep. Okay, the reason for stopping it and backing it out is to avoid that chatter when the tool moves in reverse. This way I ensure that I get a nice clean cut. Right, so the through hole is 43 millimeters wide diameter, and the recess is got a 45 millimeter radius diameter. I think that is enough for a plug to go in and to seat on. It should be strong enough. I don't want to take away too much. I want to keep the structural integrity of the table as much as possible. And I think that's most of the machine work done here. So what I'm going to do now is just remove the boring head and then all the clamps on this side and see how the holes lines up with the vise and everything, and run my deburring tool on this hole quickly. As you can see, the bolt holes are sitting nice and center in all the slots. This is exactly what I was aiming for. and there's plenty of meat on the sides. That means that the vice will rest nice and steady on this table. Even if you move it a little bit out to the sides, it doesn't matter. It's large enough not to interfere. So yeah, overall I'm happy with the table, and it is extremely rigid. You can press down on it, it doesn't move. So yeah, I think my brother should be happy with this thing. Now just to bring it to scale for you, here's the old table, and as you can see, it's considerably smaller, and it's also not flat. And one advantage of having this out of aluminium is the fact that it won't rust. So yeah, I hope you enjoyed this one. Until next time, cheers.